still remembers, so you know she was good. Some of it.
All right. So here we go. Here we go. All right, so number 6 in our 9-4 notes, it says find the limit of the following. Now, limits are a big part of the calculus, so we need to make sure we sort of get this idea. Start with these first ones. Now, when we say limit of a sequence like this, what we're talking about is where are these terms going? Like if you put them on a number line, if I drew a number line, and here's 0, and here's 1, and here's 4, and here's 9, and so on, where are they going? What? Well, they're going positive. Infinity, exactly. These things are going to infinity. Now, it's okay with me if you say positive infinity is your limit. But when we have a limit of infinity, what that really means is there's no stopping point, right? So there is no like actual wall. This would be a limit right here. There really isn't one in this problem. And when a sequence doesn't have a definite limit, it is called divergent. So while it is okay, and I'm not going to mark it wrong if you put positive infinity, a better description of that is divergent. That's what it means. There's no limit. This thing just keeps going forever better. All right, what about this next one? Now think about these numbers. Type them in on your calculator if you'd rather have decimals. But what seems to be happening to these numbers? If you were, like here's 0 on the number line, if you were to put these on the number line, what seems to be happening to them? Gio? Well, so absolutely, in terms of what we talked about yesterday, this is, what kind of a sequence is it? If we're multiplying, it's a geometric sequence. We're multiplying by 1/3. We have a formula for all that. But today the question is, what's the limit? So if we kept multiplying by 1/3, what is going to be happening to the size of these fractions? They're going to be getting smaller and smaller and smaller, right? So if here is 1/3, then here would be 1/9, then here would be 1/27. Where are these terms heading? Are they going to just keep on going all the way down like that one did? No, where are they going?
0.
They're going to 0. So the limit for this problem is 0. The limit is 0. Those terms will never be 0, but if I just kept plotting them, aren't they going to get closer and closer to 0? Yep. Perfect. All right, one more. What about this guy?
Does it keep getting multiplied by -2?
Okay, so it's getting multiplied by -2, which means it's also geometric. We could do our formula and all that, but what we're trying to figure out is there a wall? Like this problem had a 0, and that was the wall. Is that happening in this one? Think about graphing this one. Here's 0. The first term is -2. The next term is 4.
Would it be both?
The next term is -8. The next term is 16. What's happening?
It would be positive or negative.
It's going positive and negative, but each time it goes positive and negative, it actually goes further out. So what does that mean? If it's getting further out, if it isn't coming closer to something, it's divergent. Now, for this problem, you can't say positive infinity, all right? Every sequence has one limit. And do these keep going and going and going? They sure do, but don't they also keep going and going in this direction? So we say divergent. This one is divergent. There is no limit at all. Do not say infinity because it's going both ways. See the difference between the first problem and this third one here? Caden, see it? All right. Now, those first three problems were written out as an actual sequence. All the rest of these are written in kind of weird set notation. I want you to think back. I hope you can remember way back to chapter 2. Now here's what the problem looks like on the paper. But I want you to think back to chapter 2 when we were graphing things like this. And we put asymptotes in and holes and intercepts. Remember all that conversation? How did we find the horizontal asymptote? Does anybody remember? Gio?
Y equals X over B?
We looked at the highest powers of the variable. Remember boxing that in, you guys? Remember that? And that's how we got the horizontal asymptote. So for this problem, the horizontal asymptote would be y equals 1, x over x. The horizontal asymptote is the limit. So I'll write that down. The horizontal asymptote is the limit. So you're gonna, when your problem is written this way, kind of, as a fraction like this, you're gonna look at the highest power, this time it's n's. So the limit of this would be what? 1, n over n. So this limit is 1. What about the next one? The next one is 2n minus 8 over 3n plus 6. What's the limit of that?
2/3.
2/3. Very good. Kids, isn't it easy? It's just like our horizontal asymptotes. It was so easy. You just look right there. How about the next one? 4n, did I skip it? No. 4n squared plus 6n minus 3 over 5n squared plus n plus 1. What's that one? What? 4 over 5. Remember, we look at the highest power. Because as n gets big, which is what happens when we talk about limits, as n gets big, this is the dominant force of the problem right here. So 4n squared over limit is 4/5. I'm sorry, 4/5. Now, you knew it was going to get a little bit trickier. What's tricky about the next one? There's no squared on the top. And the reason Gio's looking for the squared is because we look for the highest power. Now, who remembers what we do when we're missing it? We put in a 0. So this is going to be 0n squared. So when I build my box, what do I end up with? 0. So the limit of this one is 0. Gio?
Will we get it wrong if we put 0 this?
Yeah, you want it, not totally, but remember, we simplify everything. So 0 divided by 5 is 0. Okay, now what about this one? Who remembers this kind of situation? Isn't this the same thing? Aren't I missing my n squared? Jocelyn, you okay today? Okay. I'm missing my n squared, so I'm going to put a 0 down here. Now, is that problematic for me?
Yeah.
Yeah, because I'm not allowed to have 8 over 0, right? So if I'm not allowed to have 8 over, what do I do? Undefined. So back when we were doing asymptotes, we're graphing these things, we said there's no horizontal asymptote, like we wrote none or something like that. What are we going to write in terms of this? If we didn't get an answer, we're doing a limit. What is our word for that? No. No limit. What's our vocabulary word? Divergent. So we're gonna write divergent for this one. If you can't get an answer, in other words, if there is no limit, you're gonna write divergent. All right, so are we good with that kind of problem? Because that's all the examples I have for that type. Now we're gonna look at another type. Are we good with this? Okay, real quick. What if we said find the limit as n approaches infinity of this thing?
2/3.
What'd you say?
2/3.
She said 2/3. Anybody want to agree or disagree with that? Thumbs up? Yep, 2/3. Because what's the highest power in the problem? N cubed, right? And I've got 4 of them over 6 of them, which reduces to 2/3. So if I were graphing this, heaven forbid, I would have a horizontal asymptote at 2/3. Right? Okay, now the next problems look a little bit different. We're finding the limit, that's what this means, we're still finding the limit. But now we have fractions to powers. So I want you to look carefully at these two problems and look at these. Do you see how they're just built differently? Yeah. Okay? They're built differently, so you gotta pay attention to that. All right, let me get the last 2 up here. Okay, so here we go. We're gonna find the limit. Now, when I say 2/3 to the nth power, what numbers am I talking about? Well, what?
The limit.
I'm going to be talking, I'm going to find the limit, but to help me figure that out, this, if I put n equal 1, I would get 2/3. What if I put n equal 2? What's 2/3 squared? Okay, we got calculators if we need them. And Gio's reaching for his, good job.
0.4 repeating.
Okay, so this one is 0.6 repeating, right? And then you get 4/9, which is 0.4 repeating. Okay, all right, let's do one more. What happens if we cube that? We'll put a 3 there. What's 2/3 cubed? What decimal is that?
0.296296.
Okay, now, what's happening to those decimals? They're getting smaller. Now, I want you to think about this. We talked a little bit about it yesterday. If we keep multiplying by 2/3, this means 2/3 times 2/3 times 2/3 times 2/3. If we keep, and so on and so on and so on. If we keep multiplying by 2/3, is our answer going to get bigger or smaller? Smaller. If this number right here is less than 1, then it's just going to keep getting smaller. So what does that mean the limit is? If it just keeps getting smaller, if these decimals just keep getting smaller and smaller, what's the limit going to be? 0. That's exactly right. Good job. The limit's going to be 0. Now take your calculator and let's do this one. And I don't even want you to worry about the funky exponent. Let's just forget that for a second. And let's just talk about what happens when you multiply 5/4 times 5/4 times 5/4 times 5/4, and so on and so on and so on. Go ahead and do it on your calculator.
It's bigger.
Take 5/4, multiply it by another 5/4, multiply it by another 5/4. What is happening to those answers?
They get bigger.
They're getting bigger. They're getting bigger. Because 5/4 is 1.25. And when you multiply by 1.25, you get a little bit bigger. So these terms, and it doesn't matter what the exponent is, guys, so don't get hung up on that one bit. Don't worry about that exponent. You are multiplying by 5/4. And if you multiply over and over and over again by 5/4, your answer just keeps getting bigger and bigger and bigger. So what are you gonna put down as the answer? What's the limit of this? If my numbers just keep getting bigger and bigger and bigger, my limit is a positive infinity, for sure, if you wanna write that. Or, what's our vocabulary word? So this one, you could put positive infinity, because that's exactly what's happening. Or, you could write divergent. Now, big picture. What's the difference? Why did this answer be 0? Why did this one go to 0? And this one is divergent. This one just gets bigger and bigger and bigger. Tell me.
The first one's smaller than 0.
What?
The first one's smaller than 0.
Not
Well, smaller than 1.
Smaller than 1. That's the key. If this number right here is smaller than 1, I don't care what it is, I don't care what its exponent is, the limit is going to be 0. If this number right here is bigger than 1, it is not going to have limit. It is just going to keep exploding. Now, I am going to try to trick you by putting in all this weirdness, all this weird exponent stuff. Ignore it. What matters is the size of this number right here, the base of the exponential, right here. So that's a 1.5. What's gonna happen to this one? What's gonna be the answer to this one? Divergent. When you have an exponential, a number to a power, your limit is either going to be 0 or no limit, okay? This one is no limit, divergent, infinity. What about this one? Again, we're not concerned with this. What's happening? That one's gonna go to 0. Okay? Pull out your 9-4 homework. There's a couple of these at the bottom of it. I wanna make sure we have this under control. So pull out your 9-4 homework. We're gonna do the last 3 problems. All right, 4A. What's the limit of that expression? Now, I told you, I'm tricky. Look at it carefully. What are you supposed to be comparing? The biggest power. So what have I got? I've got an N here, and I've got an N here. So they're not on top of each other, but it doesn't matter. The limit's gonna be what? Negative 3/4. Negative 3/4. How do you feel about that? RJ, you got it? All right, let's look at the next one. Next one's exactly like what we just talked about. This is one where we have a number to a power, and the number is 3/4, and that's all I really care about. Since it's a 3/4, the limit will be 0. Because what's our rule, Sydney?
It's not bigger than 1.
Exactly. If this number is less than 1, we're going to 0. If it's bigger than 1, we're divergent. And then, cut off the last one. It's another one that's a little bit tricky. Anybody want to hazard a guess here, besides Geo and Scout? What? Very good, Sydney. And why? Sydney said this is divergent. Why?
Because 0's on the bottom.
Because we don't have an n squared on the bottom, and when we put an n squared down there, we're going to end up with 2/0. Next week, when we have our quest over all this, we're gonna have problems like that. So does anybody have a question about one of these three from the homework? You? Got it? All right, let's put that away then, and let's move on to 9.5. All right. I'm gonna put two problems up here on the board. You don't have to write them down. I just want you to think about them. I'd like you to think about, I have a piggy bank, okay? I have a piggy bank. And I'm gonna put some coins in my piggy bank. So on day one, I deposit, I'll say 10 cents. On day two, you don't have to write this down, just listen. I'm gonna deposit 12 cents. On day three, I'll deposit 14 cents, and so on. Now, I'm gonna ask two questions, and I want you to tell me if they're the same or if they're different. First question is, how much will I deposit on day, I don't know, 16? And the second question is, how much will I have deposited on day 16? Now, are those, okay, so here's the setup. Here's my bank, putting in 10 cents today, 12 cents, da-da-da-da-da. Here are the two questions. Jacob,
They're different
what's different about them?
because the first one is saying how much you're going to do on the 16th day, and the second one is how much you will have done by the 16th day.
So in other words, this is how much I'm dropping in the bank on day 16. And this is, if I pick my bank up, how much is in there altogether. Does everybody see the difference?
Yep.
Now, question number one, we can do. We did it yesterday, or ones like it. What kind of a sequence of numbers is this?
Plus 2. So
What?
it's like plus 2.
So it's, I'm adding 2, which makes it what kind? What's the name for that? Arithmetic, right? And the common difference is 2. So I'm gonna do this problem right here. So I know it's arithmetic, and I know the common difference is 2. Look up your formula, or maybe you haven't memorized already. What is the formula for an arithmetic sequence?
A16 equals.
Okay, wait on that for a second, Scott. You're giving me the actual, like, setup for the problem. Can you give me the general formula first?
AN equals A1 plus 50 times N.
Right, and remember, we don't have to memorize that formula, but we have to know that formula is arithmetic sequence. Because I'm gonna give you a paper with all the formulas on it, but I'm not gonna tell you what's what. So you need to know, okay, that's the one for arithmetic. There's a D in it. Okay, now, what did you say, Scout? For this problem, I'm gonna say A sub 16.
Yeah, plus 10.
10 equals 10.
Yeah, equals
Plus
10 plus 2 times 16 minus
16 minus 1, I'll just put 15, is that okay? So how much money am I putting in the bank that day? $0.40. So the answer to question number 1 is 40 cents. That's old news, right? Gio, you got it? You okay? That's question number 1. Oh yeah, oh no. This question number 1. Yeah, we haven't gotten to the notes yet. We're going there in a second. Now, this one doesn't say list them. This is just like a list, 10, 12, 14, dot, 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 dot. This one says take that list and add them up. Would you agree with that? That's what we're doing here. All right. I got a cool story about this, so I'm gonna tell you a cool story, and then we're gonna actually do the question. All right, and then we'll do this, and then we'll get to our notes. All right, so here's the story. Imagine back, I don't know, I think it was the 1700s, but I could be wrong, could be the 1800s. And it's over in Europe, someplace, and all boys in school, it's an all boys school, classroom full, all little boys. They're like third grade or something, there's some little boys. It's a true story, it's in the encyclopedia. You know what that is, right? You can Google it, it's a true story. The teacher says to this group of boys, little kids, they're kind of getting antsy. He says, okay guys, here's what I want you to do. He's just trying to keep them busy till the end of the day. So here's what I want you to do. I want you to add up all of the numbers, counting numbers, from 1 to 100. So in other words, I want you to add up this. Now, these were like third graders, they could do this, and it was gonna keep them busy for a long time, because what would you do? If somebody said do this, wouldn't you say, okay, 1 plus 2 is 3, and 3 plus 3 is 6, and 6 plus 4 is 10, and so on, right? You just keep doing that. So the teacher gave this assignment to this classroom full of little 9-year-olds or whatever, and next thing you know, up came this little boy with the answer. I mean, right away. And the teacher said, how did you do that? True story. And he said, well, you're asking me to add up all these numbers, and I don't know what that equals, but I'll call S for the sum of all these numbers. I do know, though, that I will get the same answer if I add them in the other order. True, right? You can add in either order. Well, if I add these two together vertically, so 2 of my sums, look what happens. What happens all the way down the line? These 2 add up to 101. What do these 2 add up to? 101. And these 2 add up to, and they're just gonna add up to 101 all the way down the line. True? Well, how many 101s are there? No. How many numbers were we adding up? 100. Aren't there 100 of those 101s? So I have 100 of these 101s. So 100 times 101 is twice my answer. So if I divide by 2, my sum is 50 times 101, so the answer is 5,050. Okay? Now, a little kid did that. His name is Carl Friedrich Gauss, one of the great algebraists of all time. True story, look him up, G-A-U-S-S. It'll have this about it. It's amazing. So how does that have anything to do with what we're doing? Well, is his sequence, here's mine. Is his sequence kind of like mine? Yeah. Isn't it arithmetic? So I'm going to use his formula to do my problem. Now, in his problem, where did that 50 come from? That 50 came from taking 100 divided by 2. And the 100 was how many terms he had? So if I want to add up n terms, I'm going to divide n by 2. I'm going to do 100 divided by 2. Now where did his 101 come from? Where did that 101 come from? I added the first term to the last term. That, my friend, you need to write down at the top of your page. That is how you add up the terms of an arithmetic series. So it has to be arithmetic. Make sure you're writing next to this, arithmetic. Because we're going to do geometric here in a minute. Maybe. Okay? Now let me finish this one. Again, you didn't have to write any of this down, but let me finish this one since I started it. Go back to my bank problem, which I've erased. How many days was I adding up? How many days was I making deposits in my bank? When it's 16? So the sum of 16 terms, according to that formula, will be 16 over 2. What was my first day? 10. What was my last day? 40. And that's how much money I'm gonna have in my bank. So you've got a calculator, go ahead and do that. But I think it's gonna be $4. What's the matter? Scout, is
Oh,
that not right?
sorry, this is in cents?
Yeah,
Oh,
this is
okay.
cents, yeah, so you should have gotten 400,
Yeah.
which, no, let's be honest, nobody says 400 cents, right? So I'm gonna answer in dollars, but yeah, that is 400 cents, because these were cents here. Alright, so we got all this stuff I'm talking about and all that. This is what is important for you to have written down. Here we go, number A. You are gonna find the sum of all of these numbers. Caius, how many numbers are there?
8.
Alright, so in terms of my formula, I am gonna be adding up 8 numbers. Did you count right? Yeah. My formula says 8 over 2. What does this stand for? First term, and the first term is negative 18. Now remember, this formula has 3 n's in it. So that's 8, that's 8, that's 8. So this means the 8th term, which is, turn your paper, what's the 8th term? 17. So what do we end up with as our answer? Negative 6? I'm getting negative 4. Negative 4? Double check that, Gio. Did you get negative 4? Okay, is that alright with everybody? Alright, let's look at B. Tell me about B. Erickson, you got a thought about B? What seems to be happening in this sequence? Times by what? Yeah, we're timesing by 3. So we're multiplying by 3, which means we are not arithmetic. What are we? We're geometric, and the ratio is 3. Now, will I be using that formula right there? No, because that formula will add all these up, but only if it's arithmetic. So you need a geometric formula. I'm not gonna tell any cool stories, just gonna give it to you. Your geometric formula looks like this. Now again, you do not need to memorize these formulas. We're up to 4 now. We got 2 yesterday, we got 2 so far today. You don't need to memorize them. But, see the S's? What do you think those S's stand for? Sum, we're adding. So if your job is to add, you're going to use an S formula. See this R? What does an R stand for? common ratio, and if it's a common ratio, then the sequence must be geometric. So you see how you can figure out that this is geometric sum? Okay, because that's what you gotta know. I'm just gonna give you the formulas. All right, so let's see if we can use that formula. We've never used it before, but we know what all those letters stand for. Let's see if we can figure it out. How many terms am I adding up? How many terms do we have in this list? 5. So we're gonna find S sub 5. Every n in the problem then is going to be a 5. What does a sub 1 stand for? First term, we know what that is, -2, minus another -2 times r, which Ayrton figured out was 3 to the 5th, divided by 1 minus 3, which is -2. Now, I want all the calculators out. We're gonna practice typing this in. I love Scout's idea. The first thing Scout did was make this a -2. That's going to make typing in easier. So go ahead and just do that quick subtraction. So now it's -2. If you type it in exactly the way that I wrote it with the parentheses and everything, all's gonna be good. So -2 minus parentheses -2 parentheses 3 raised to the 5th power equals, whoops. Told you to type it in exactly like I said, and then I didn't. Did you hit equals after your numerator? What'd you have for your numerator? 484. And then divided by -2. And that's -242 is your answer. Because this right here is multiplication, we could have canceled those negatives. So if you're comfortable with that and you do it carefully, you can cancel those because you're subtracting a negative. You can go ahead and cancel those if you want. I like to just type it in like it is, and that way I don't make any careless mistakes, but you could cancel. All right, everybody follow that? All right. Couple more to get through here, then I'll shut up. Alright, so what's going on in this one? That's the first thing you have to figure out, kids, is what kind of sequence do I have? What kind of sequence do we have here? Arithmetic? Arithmetic? So that's this formula? Is there anything that's bothering you a little bit?
We don't know how many terms.
Say it again, Scout.
We don't know how many terms.
We don't know how many terms there are there. Do we need to know how many terms there are in order to use this formula? Yeah, it's pretty important. So, this is a tricky problem. If you don't have all the information you need for this formula, then you gotta go back to yesterday's formula. Now, Mrs. Ford, how is that going to possibly help me? Well, I don't know how many terms there are, but I know that 53 is the last one. So if there's 18 terms, this would be A sub 18. If there's 25 terms, this is A sub 25. Does that make sense to you? This is the last term. So my formula says 53, the last term, equals the first term plus the common difference. What's our common difference? 4 times n minus 1. Now, am I gonna be able to figure out n? From here, can I figure out n? Yep. And as soon as I know n, I'll plug it back in this formula and I'll be home free. So let's solve this. What do you wanna do to solve this? You got some options. Distribute, okay, that's one option, and if it makes sense to you, do it, do it, do it. That's exactly perfect. All right, so Gio, this was your idea. What do you wanna do now that we distribute it?
Let's subtract 4 by 5.
So combine these two, sounds like a wonderful plan. So what is that, 1? Okay,
Take a little one
so
of
52 equals 4n, perfect. And 52 divided by 4 is 13. Remember, you have a calculator for everything, so don't stress about the arithmetic. Now, that is not the answer to the question. This was the question, remember, to add all those up? What does this tell me? There are 13 numbers in that list. Some are missing, but there's 13 of them in that list. So S sub 13, I'm using my formula now to add them up. S sub 13 will be 13 over 2 times 5 plus 53. Go ahead, let's figure that out. And we should be all set. What'd you get?
Negative 312.
That's not what I got. I could be wrong. Let me try it again. Wait,
377.
how did you get a negative number, Scout?
Oh, I subtracted 5 and 53.
Oh, no. The formula says add, right? You just do what the formula says. So what did somebody else get? 377. Yep, that's your answer, 377. Now, this happens a lot with your arithmetic sequences, where you don't have all the information, so you have to use the first formula to get your n, and then you can plug it in and get your answer. That's a 2-step problem, and it happens a lot. Hint, hint, probably will happen on your quest. All right, last one, D. What is happening in problem D? What kind of a sequence do I have? Yeah, what am I multiplying by?
4.
What'd you say, Hugh?
5.
Hugh thinks we're multiplying by 5. Take 0.08 times 5. And do we get 0.4?
Yes.
And then if we take 0.4 times 5, do we get 2? So I think he's right. Now, Hugh, how did you figure that out? Because I think some of us are having a hard time figuring out that we are multiplying by 5. Do you have a strategy to figure that out?
I just divided 2 by 0.4.
Hugh said he took 2 divided by 0.4. And then it would be a good idea, Hugh, to double check and maybe do 0.4 divided by 0.08. And those numbers have to match. It's called a common ratio because the fraction, this over this, will be the same as the fraction this over this. Very good, Hugh. Very good. So if you're not sure, if you think, well, I think I'm multiplying, but I'm not sure, go ahead and do the ratio. Third divided by second will have to match second divided by first. Okay. All right, we're gonna add these up. There's my formula, it's geometric. There's my geometric formula to add. Crap, do I know how many of these I have? How many terms I have? I do not. I do not. So, you got a couple of choices. Could you keep timesing by 5 to see how many times it takes you to get to 1250? Yeah, but depending on that number, that might take a very long time. So could we do this like with our math? Gio?
Couldn't you divide the ratio by the final term to get the, like, amount of problems or?
The amount of terms?
Yeah.
Well, let's just check that out. So you're gonna take 1250 and divide it by 5. I got 250. All right, now I'm gonna do it mathematically and see if I get the same thing. All right, it's a good idea. Let's see if it works. So, what did I do in the last problem when I needed more information? I went back to the other formula. So, here's my other formula for geometric. 1250, try to hang on guys, we're running out of time. 1250 is 0.08 times the ratio to some power. I'm trying to figure out that right there. So, any ideas how we might start that problem? How about if we divide by 0.08? We did this kind of thing back when we were working with logarithms. We could do this problem with logarithms, but I think it's just as fast to do a little trial and error. This says if you take 5 and raise it to a power, you're gonna get that number right there. So I'm just gonna pick a number. What would be a number to pick? 5 raised to the what? Huh? 2? Well, I know what that is. 5 squared is 25. Okay, that's not big enough, Scout. I'm trying to get this number right here. So maybe 12? Oh no, 5 to the 12 is 244140625. That one's very much too big. So something in between 2 and 12? 5 to the 8th? 390625. I'm getting closer. I'm still too big? What do you want to do? 5 to the 6th? Oh, there it is. 5 to the 6th is 15625. So this number right here is 5 to the 6th. Just did it on my calculator. If this is 5 to the 6th, what does my n have to be? Is 5 minus 1 6? It has to be 7, doesn't it? 7 minus 1. So n is 7. All that messing around was so that I could find my n value. So the first term is 0.08. R was 5. N is 7. Here we go. We're going to type that in on our calculators. First, let's make this a -4 to make it easier on ourselves. So 0.08 minus 0.08 times 5 to the 7th equals, always hit equals before you divide. Yep, 1,562.48. Very, very good. If you didn't get that, type this in again, the numerator, exactly the way I wrote it. Hit equals, and then divided by -4. Okay, those are tough problems. Those are tough. I'm going to stop there. Your homework, remember, you got an assignment on Tuesday. which we did some of it.